All right, my friends, this is the part of the video where you're going to need a compass and a straight edge. A straight edge, you could use, your ID card if you really needed to. And then a compass, if you have one, go find it. If you don't have one, this is not worth a trip to the store for. You could always kind of fudge it if you need to. So, and it is a small part where you'd need one. So, all right. Let's talk about different ways to prove two triangles congruent from back in the day in geometry. The idea is that, let's say you have two triangles, or let's say you want to copy a triangle perfectly, like how could you copy that triangle perfectly? Create something that is exactly the same shape and exactly the same size. One way would be would be to show that all of the pairs of side lengths are the same and all of the corresponding angle measures are the same. You could do all that. It seems like that would be overkill. Let's see, what was that? What was that called though? Congruent parts, or no, corresponding parts of congruent triangles are congruent. There we go. There's that. Anyway, but that's a lot. That's more work than we really need. So it turns out that if you don't do the angle measures, if you just do the side lengths, then you could actually, copy one triangle to the other, and they would end up being congruent. And you probably did that with a construction at least once back in geometry. And so you could also get away with what's called side, side, side. So where you just copy the side lengths between the two triangles. You could also get away, what else could you get away with? Could you get away with angle, angle, angle? Just copying the angle measures? And the answer is no. You could make sure, that you have similar triangles, but they're not especially the same size. They might be the same kind of shape, but not the same size, if that makes sense. So angle, angle, angle should not be in our list. Let's see, what else could we get away with? We could get away with side, angle, side. If you were to copy, let's say you copy like these two sides from one to the next, and then you copy just that angle measure from one to the next, then you would have created a perfectly congruent triangle to this first one. Let's see, what else was there? There was side, no, there was angle, angle, side, right? Angle, angle, side, I think. Yeah, let's see. Would that make sense? We're like, you copy this bottom side length and you copy this angle and this one. And that's all it would take to make a perfect copy of this triangle. So yeah, that's one. Let's see. So I feel like I'm missing one. Oh yeah, I'm missing angle, side, whoops. Angle, side, angle. And that one, whoops, that's the one I just did. That's so funny. Angle, side, angle, that's this one. Angle, angle, side, that's where the side was not included. Like that. Like that, yeah. Yep, you could totally, okay, very good. That's another one. Okay, and then if you start playing around with combos of, A's and S's, then sooner or later people are gonna, get that one in the list, right? With the, not necessarily in that order. And so the joke in geometry is that if you spell this one backwards, if you spell side, side, angle backwards, then that's what it would make out of you if you try to prove two triangles congruent with it. And so anyway, so the point is that one should not be in the list. And as a matter of fact, the whole point of this part of the lesson is that if you have two side lengths and an angle measure, if that's what you're given in a law of science solving type problem, then you actually could have what's called a two-solution case. And so, so the whole point was to get to this part where you talk about how this should not be in the list. And so now we're going to talk about how something like this could turn into a two-solution case. And that's where the compass and straight edge comes in really handy. So what we're going to do is we're going to investigate this side-side angle case. So to do that, let's start a little construction for anybody who's been missing geometry, right? So let's see, every construction seems like it starts out the same way, right? You draw a straight line, line segment longer than you need it to be. And then the next thing you do for this construction is we're going to need to have an acute angle over here. So So go ahead and you can just freehand it. Doesn't, just as long as that's a fairly acute angle measure, it'll make it easier to draw the rest. And then what I'd like for you to do is take the base of the compass, that's the dangerous part, and put the base of the compass here at the very top of this segment. And then make sure that the compass is open just a little wider than this distance between where the base is and this like line down here at the bottom. Make sure it's open a little bit wider. And then just kind of, oops, mark off, sloppy. There you go. Okay, so mark off where that arc would intersect with that bottom line. There you go. Okay, now that we've got that, what you're going to do is take your straight edge and you're going to connect this end point of this top segment with where the arc intersected with that bottom line. And then do the same thing with the intersection over here. There we go. Okay, now before we continue and I show you where we're going with this, I'm going to point out some fairly annoying things. So some really like kind of strangely obvious things. For example, that angle is totally congruent to itself. This side length right here is totally congruent to itself. And then lastly, because of the way we did this construction, this is congruent to that. There you go. Okay, now as exciting as that was, the next thing I'm going to do, and I'm going to use patty paper because, man, I have tried to copy these different parts out of the picture, freehanding it a couple times, and it's been just a major disaster every time. Let's just say this isn't the first time I've recorded this video. Anyway, what we're going to do is we're going to pay attention to this triangle that's on the left side of this picture here. And I'm going to copy it. You could just freehand it. I pretty much promise that your freehanding is better than mine. Okay, so I'm going to copy that triangle out. And this paper smudges. Oof. Okay. So that's that triangle right there. And it has this angle, this side length, and this length right there. Okay. And then I'm also going to copy, this time the whole triangle. So not this isosceles one that I'm coloring, like the whole thing. So after this one, I will not be nearly as careful. It's just always nice if the first one looks kind of good. There we go. Okay, so this is a copy of the outside one, and I'm going to copy the congruent marks that would carry over. So this angle, this side length, and then this side length. All right, my friends, and back in geometry, it was this activity that you would have done to show why, if you know two side lengths and a non-included angle measure, why it doesn't make sense for you to, based on that information, to claim that the triangle would be congruent to another one that has that same information. Because you can see you get two very different triangles, even though they share two side lengths, two pairs of congruent side lengths, and a non-included angle measure. And what that turns into for us, now that we're in pre-calculus, is it turns into what's called a two-solution case, where if you're given 2 side lengths and a non-included angle measure, then you could potentially get 2 different triangles that satisfy that. All right, my friends, so I'm going to go ahead and give you the next example and have you do what you can do with it, and then we'll talk about it together in the next video. So see how far you can get without me. So the directions are for you to find 2 triangles. Oops. For which A equals 12, we'll say meters. This is a nice big triangle. B equals 31 meters. And A equals 20.5 degrees. All right, see how far you can get. At least solve for 1 triangle, because I know you could do that. And then put your mind to seeing if you can figure out how to get the second one. Big hint. When I do it, I'm going to draw this master picture, and then I'll draw these 2 pictures as well to figure it out. Good luck.